Hey everyone, welcome back to the channel. Today we're diving into a story that sounds straight out of a sci-fi movie, except it's very real. NASA and astronomers worldwide are tracking an asteroid named 2024 YR4, which has a small but unprecedented chance of colliding with Earth in 2032. Now before you panic, let's be clear, the odds are still low, but here's why this asteroid has scientists on high alert. Its impact probability has doubled in just weeks, it's large enough to level a city, and it's now ranked level 3 on the Torino scale, a rarity for near-Earth objects. In this video, we'll break down everything you need to know, how it was discovered, why the risk is rising, and what NASA's James Webb Telescope is doing to help. Plus, we'll explore what a city-killer asteroid actually means for humanity. Before we jump in, I want to let you know that in the description below there's an ad link. Just a heads up, it's not a paid promotion, it's simply a link we share to support the channel. Don't forget to like, subscribe and hit the bell for updates. Now let's get into it. Imagine a space rock hurtling through our solar system, a rock so significant that if it were to hit Earth, it could wipe out an entire city. That's exactly what 2024 YR4 is all about. Discovered on December 27, 2024 by the Asteroid Terrestrial Impact Last Alert System, ATLAS, in Chile, 2024 YR4 is classified as a near-Earth object, NEO. It's an Apollo-type asteroid, meaning its orbit crosses Earth's path. Estimates put its diameter somewhere between 40 and 90 meters, or about 130 to 300 feet. While that might not seem huge on a cosmic scale, an object of that size impacting Earth could release energy equivalent to roughly 7.6 to 8 megatons of TNT. To put that in perspective, that's more than 500 times the energy released by the atomic bomb dropped on Hiroshima in 1945. So why is this asteroid making headlines? Because even though there's about a 97 to 98% chance that it will pass by safely, current analyses indicate that there's roughly a 2.1 to 2.3% chance, roughly 1 in 43 or 1 in 48, that it could hit Earth on December 22, 2032. Today, we're going to break all of that down in detail. Let's rewind to December 2024. Just after Christmas, while most of us were wrapping gifts or binge-watching holiday specials, NASA's Asteroid Terrestrial Impact Last Alert System, ATLAS, in Chile spotted a faint dot moving across the sky. This was 2024 YR4, a near-Earth asteroid roughly the size of a football field. 2024 YR4 was discovered by ATLAS, a NASA-funded telescope system designed to detect potentially hazardous asteroids. The discovery came at the tail end of December 2024. In fact, it was first reported on December 27, 2024, and even though it had already made a very close approach to Earth on December 25, it was only then that scientists could detect it as a distinct object. This discovery is crucial because early detection is the first step in planetary defense. With every new object we discover, especially those that come close to Earth, we get a chance to study its orbit and composition to better understand the risk it might pose. In the case of 2024 YR4, its discovery has triggered an international response and has placed it high on the list of objects requiring close monitoring. Initially, its odds of hitting Earth were a mere 1.3%, but by late January 2025, new observations pushed that probability to 2.1%, triggering formal alerts to the United Nations and global space agencies. For context, most asteroids rank level 0 on the Torino scale, but 2024 YR4 hit level 3, a threshold reserved for objects with close encounters warranting public attention. Why the sudden spike in risk? It all comes down to orbital uncertainty. When an asteroid is first detected, scientists have limited data to predict its path. As telescopes gather more observations, the cone of uncertainty narrows. In this case, Earth remains inside that cone for its 2032 approach. But here's the kicker. 2024 YR4 will vanish from view in April 2025 and won't return until 2028. That means astronomers are racing against time to study it now before it disappears into the cosmic dark. This asteroid is now the highest risk object on NASA's Sentry Risk Table and the European Space Agency's ESA Near-Earth Object Impact Risk List. The Sentry Risk Table is a list of asteroids that could impact Earth, along with their estimated probabilities of impact and the dates of those impacts. The table is part of NASA's Sentry system for monitoring Earth-threatening asteroids. The table includes the asteroid's name, the probability of impact, and the date of the potential impact. Let's talk about the Torino scale. The Torino scale is a scale that measures the risk of an asteroid or comet hitting Earth. It's used to categorize the impact hazard of near-Earth objects, NEOs. The scale ranges from 0 to 10, where 0 means no hazard and 10 means a certain collision. The Torino scale was adopted by the International Astronomical Union, IAU, in 1999. It was named after a scientific conference held in Torino, Italy in 1999. Imagine it as the Richter scale for asteroid threats. Level 0 means no hazard, while level 10 means certain global catastrophe. 2024 YR4 sits at level 3, a close encounter meriting attention but not yet a threatening event. The Richter scale, also called the Richter magnitude scale, Richter's magnitude scale, and the Gutenberg-Richter scale, is a measure of the strength of earthquakes, developed by Charles Richter in collaboration with Benno Gutenberg, and presented in Richter's landmark 1935 paper, where he called it the magnitude scale. So what does a 2% chance actually mean? Statistically, it's like rolling a 100-sided die and landing on two specific numbers. Low odds, but not impossible. For comparison, you're more likely to be struck by lightning, 1 in 15,000, than this asteroid hitting Earth. But in space terms, a 2% probability is unusually high. As NASA engineer Davide Fanocchia put it, getting something with a probability this high is rare for us. The asteroid's size complicates things further. Estimates range from 130 to 330 feet in diameter. If it's on the larger end, it could release energy equivalent to 8 megatons of TNT, 500 times stronger than the Hiroshima bomb. Even a smaller impact could devastate a city, similar to the 1908 Tunguska event in Siberia, which flattened 800 square miles of forest. But here's the catch. Size estimates are fuzzy. Current measurements rely on reflected sunlight, which doesn't account for an asteroid's reflectivity. A bright, small rock can look identical to a dark, large one. That's where the James Webb Space Telescope comes in. One of the most exciting aspects of this story is the role that advanced observatories are playing in tracking 2024 YR4. Ground-based telescopes around the world, including those part of the International Asteroid Warning Network, IAWN, have been pivotal in monitoring its trajectory. However, as the asteroid moves away from Earth, its brightness fades, and we hit a period where even the largest ground-based telescopes will struggle to keep track of it. That's where space-based observatories come in. NASA's James Webb Space Telescope, JWST, known for its powerful infrared capabilities, is scheduled to observe 2024 YR4 in early March 2025, and again in May 2025. Unlike telescopes that rely on visible light, JWST will measure the infrared thermal emissions of the asteroid. This is crucial because it allows astronomers to get a much more precise estimate of its size and albedo or surface reflectivity. By using infrared observations, scientists can determine if the asteroid is more reflective, and hence possibly smaller, or darker, and possibly larger, than initial estimates based solely on the light it reflects. This information is critical in calculating the potential energy release upon impact and refining the impact probability. Keep in mind that the period from early April 2025 until mid-2028 is a gap where the asteroid will be too faint for ground-based telescopes, but thanks to JWST and other space-based instruments, we will still have a window to gather essential data. Now, let's talk about one of the most fascinating and often discussed aspects of this whole saga, planetary defense. What if after all these observations we find that 2024 YR4 is indeed on a collision course with Earth? What options do we have? There are several proposed strategies. One of the methods that has been tested is the kinetic impactor approach. In 2022, NASA's DART mission successfully collided with the small asteroid Dimorphos to alter its trajectory slightly. While DART was a groundbreaking demonstration, experts warned that the same technique might not be effective on all types of asteroids. For example, Dr. Robin George Andrews, a UK scientist and volcanologist, has pointed out that many asteroids are rubble piles. These are loosely bound collections of rocks and dust, rather than solid monolithic bodies. If you hit a rubble pile with the same force as you did a solid rock, you risk fragmenting it. In his own words, it's like turning a cannonball into a shotgun spray, which could actually complicate matters if the fragments remain on a collision course with Earth. As a last resort, scientists have also discussed the possibility of using a nuclear explosion near the asteroid to alter its path. However, this approach comes with significant technical and political challenges, not least because detonating a nuclear device in space is prohibited by international treaties. Another, more subtle method involves using a spacecraft as a gravity tractor. The idea here is to use the small gravitational pull of a spacecraft to gradually nudge the asteroid off course over time. This method requires years of advance notice and very precise calculations, but avoids the risks of fragmentation. Emerging technologies also include the use of focused solar lasers to heat a part of the asteroid, causing material to vaporize and generate a thrust that slowly shifts the asteroid's orbit. What's key to all of these approaches is time. The sooner we know the true trajectory and size of 2024 YR4, the more options we'll have. Unfortunately, many of these deflection strategies require a decade or more to implement successfully. In the case of 2024 YR4, with an expected impact date in 2032 if it were ever to hit, our window for action is incredibly tight. Should we be scared? The short answer, no. The long answer, stay informed, not anxious. A 2% risk is still a 98% chance of a miss. Even if 2024 YR4 hits, its effects would be localized, not apocalyptic. As CBS News' Bill Harwood noted, it wouldn't be something like the rock that killed the dinosaurs, but it would be catastrophic for a city. What's truly remarkable here is the science. A decade ago, we might have missed this asteroid entirely. Today, global networks like ATLAS and cutting-edge tools like Webb give us a fighting chance. So while 2024 YR4 is a wake-up call, it's also a testament to human ingenuity. Alright, that's a wrap for today's in-depth look at NASA's asteroid alert for 2024 YR4. I hope you found this exploration both informative and thought-provoking. If you enjoyed this video, please give it a thumbs up, share it with your friends, and hit that subscribe button and ring the bell so you never miss an update. And don't forget there's an ad link in the description below. Just a quick reminder. It's not a paid promotion. It's simply there to support our channel so we can continue bringing you the best content possible. I'd love to hear your thoughts. What do you think about 2024 YR4? Are you excited about the future of planetary defense? Drop your comments down below and let's have a conversation. Thanks for watching, and I'll see you in the next video.